leader in applied intelligence.
And you lead open source, right?
We're going to read you a quick
to
introduction.
Okay.
Hey, welcome everyone. Let's get started. I'm pleased to introduce Obaid, Sarvana, and Jacob. Obaid is a biomedical engineer in Accenture's software innovation practice. He's passionate about the intersection of health and technology. And Jacob is a leader in applied intelligence. So they will be presenting a talk titled Real-Time Face Detection through a webcam using AI. Please join me in welcoming Obaid and Jacob.
All right, thanks everyone. Excited to be here. As sort of we mentioned, and might have seen in the keynote, we work for Accenture's Applied Intelligence Group and work with them. And it's a group that basically tries to figure out how to use data in very interesting ways, in innovative ways, or ways that advance a business objective. So a little bit about what we plan to do, and we want to hear something from you guys as well. So our agenda here is just to do some quick introductions. Who are we? We want to hear a little bit from you. I'm going to do a brief background on machine learning and TensorFlow, just to sort of level set so we kind of understand various different terminologies out there. Talk about this concept of edge learning, and then go straight into some code demos that we'll be stepping through. So based on that, can I just get a little room survey here? How many people have heard of TensorFlow before this? Okay. How many people have written TensorFlow code? Okay, that's a good chunk. So we had some I've heard the term, and other people have written a few. Now, of those who've written TensorFlow code, how many have written in TensorFlow, so TF files? How many people have written it in something like JavaScript or another sort of things, like interactive with TensorFlow? Okay, so we got a little mix there. Okay, and now how many people are using machine learning in an application, a project you're working on, a hobby, or you're building like a machine learning model, or you've done that in the past? All right, now you guys are trepidation, I don't know, somewhere there, maybe. Okay, that helps us. So as we go through, so there's any time there's a topic where you're like, what? We're gonna try to just look. We're gonna try to recognize your facial expressions and use those as feedback. So quick introductions. This is the session slides here. The quick introduction. So Obaid, you want to give yourself a quick introduction of who you are and what you do day to day?
Sure. Can you guys hear me? In the back? So like Jacob said, I'm Obaid Sarvana. I'm also part of this applied intelligence group. My background is in bioengineering, so I'm really passionate about how we can use all the latest tech, whether that's AI, AR, VR, everything like that in the healthcare space, and help physicians be more effective, get better outcomes for patients. I sit specifically in a group called Software Innovation at Accenture.
My role at the company is actually do open source strategy and governance. So I help Accenture take code that we might write and open source it and get it out there so you guys can use it. So getting our stuff out on GitHub. But I also lead a lot of data science teams and analytics teams. So for example, right now I have a team about 15 people, and we take a whole lot of data from thousands of people that are doing a sort of like a customer service task, and we're writing statistical models on that, predictive analysis on what's going to come down the pipe, what are they doing. So hopefully their day-to-day workload is a little more predictable, and they can understand what's about to hit them when you have a bunch of data center calls coming in and various different things. So a whole lot of data pipelines, and architectures. So we're going to start first with just a quick, brief and italic history of facial recognition here. How many people have here done any sort of facial recognition technologies or interacted with them? Okay, so a few. So just quickly, because I think it sets a little context. So back in the 1960s, there was this gentleman, Woodrow Wilson Bledsoe, who basically developed this idea that there's patterns within systems, and that we can use those patterns for programmatic reasons, right? Seems very, of course, that's what software is. but at that time it wasn't quite that way. And what we were pointing out here is they developed a system to take a look at a face, find landmarks within that face, like a mouth, eyes, lips, etc., draw mathematical equations between them to find some sort of predictive patterns about that. Maybe that could be age or gender or things of that nature. Now, at this point, it was still very manual, and the number of markers or landmarks on the face were very shallow, just a few of them. But it was provable. So fast forward to the 70s, we had some more advances. Same thing, that was just a few markers, and now 21 markers. We fast forward this to the 80s and 90s, and we get this eigenface approach, which then looks at it from a different perspective, and looking at the dimensionality of a facial pattern or a 2D plane, and able to find 100 different, that with less than 100 unique dimensions, you could predictably create a pattern that would recognize an image, or in this particular case, a face. So we're able to then apply, okay, here's some manual math of landmarks, the difference between your nose, your eye, your eyebrows, to your lips, etc. Using it in a different form to then take a 2D plane of an image and then also recognize that as an image. You want to add anything to the eigenface one?
Yeah, well, for the philosophers in the room, I used to tell a joke in college. I took Phil 101, so I can make the philosophy references and not come out as overly conceited. But if you guys have heard of the Platonic ideal, so the ancient Greeks were very obsessed with what is a thing, what makes a face, what is love, all those kinds of things. So that's very much the approach that was before of what is a face, what are the rules that make up a face. And then around this time, this is sort of a shift between going from that and saying like, what's the human interpretability of what a face is, and creating sort of that rules engine that we've seen, and going to a more computational sort of approach. So for those who's familiar with the eigenface approach? A few of you. So basically what it is, it's a lot of linear algebra, but what you do is you take a lot of faces and you extract sort of what are called principal components. So what are sort of the base attributes?
I'll Vanna White this. This is eigenface right here. That's what you're looking at.
And so when you come across a face like Jacob's beautiful face, it's some linear combination of these. And that's how a face is described, some combination of weights of a series of faces. But the shift is that this has no sort of, it's very difficult to interpret this like from a human level. And I think that represents a larger shift in computing where we go from this rules engine, a lot of the algorithms are if this then that, to something that's very kind of computationally focused of provide the framework for the computer to interpret and understand from a mathematical perspective.
So this was a huge advancement of the field. And you can see that was in the 90s here, but we wrote here it's possible but impossible. So mathematically it was possible, but it was impossible because our CPUs were not strong enough, they were not fast enough, memory wasn't there. We just couldn't process the data fast enough. The algebra was provable, just too slow. So we fast forward again, and it's been a little over a decade, and then DARPA enters the picture. You guys heard of DARPA?
A few of you.
Has anybody heard of the internet? Okay, all right, just making sure. So DARPA with ARPANET turned into the internet. Well, guess what else they did? DARPA took a bunch of money effectively and ran a program for a decade and said, we want to advance this. Like, we have some good math. We have some good approaches, but what can we do now to really advance that? And so they, gave out grants, gave contracts out to companies, and they really accelerated this field to bring in more ideas. And at the same time, we had sort of Moore's law coming into effect where CPUs were increasing quite rapidly. We had quarterly improvements. The technology around this whole space was getting bigger and bigger and bigger. Then, 2007, social media explodes, or begins its sort of like, meteoric rise. And I think the biggest approach there is now we're uploading photos everywhere. So if we looked in here, they built a data set, looking at our notes, I think it was like 4,000 photos across about about 850 humans. So they took about 850 people, photographed them, and digitized those images, and it turned into a data set of about 2,500, 2,800. It was pretty low by today's standards. But this data set was huge. You can become part of the Ferret program, which is a facial recognition program, and your data set is like 2,500 photos. Now, I mean, if I wanted to get 2,500 photos of any one thing, I could go to Google and get that. So that was a big sort of momental shift of the data sets that we had, which means things that we can then train our models on. Anything going to add to that one?
No, I think that's good.
Okay. So from here, it's kind of like, the rest is history. We had this other little blip that was a historical thing where law enforcement started picking this up way back in 2009. We have a lot of news about this recently, but it was over 10 years ago where they actually used it to compare mugshots. And then we get all of our CSI shows and like NCIS where, they're doing little landmarks and all of a sudden, the person's found in like Tahiti or Paris. I found them.
Enhance.
Yeah, enhance. Just enhance it just a little more. Okay. So that brings us to this stage, the jungle stage. We're not more than 10 years ago around that, and things are just a little sort of chaotic. Things around the environment were growing. We had APIs being introduced. We had programs and projects being introduced, but it's a little sort of jungle-ish, as in some of the technologies were really good, but they were very slow. Some of the technologies were there, but they were horribly unpredictable. So we're just sort of in this phase where you could do it in the early 2000s and in the mid 2000s. Facebook released some really good research papers in 2011, released something in 2014 with deep face, not deep fake. So they had the deep face program, but you had to be a PhD, you had to have a large amount of computing resources. I mean, it was just a little chaotic.
Yeah, it was really fertile ground. I think even from within the AI space, I think we're talking early, mid-2000s, a lot of funding coming from the likes of Google, Facebook, other companies, a lot of really good approaches, a lot of really interesting machine learning, artificial intelligence stuff. But for someone like me, very hard to navigate. I wasn't going to be able to open up a paper and parse through it and really understand what's going on. So you really needed a guide or somebody with a machete to kind of cut through and guide you through the AI jungle.
And because we're in LA and we're using this jungle analogy here and things were a little chaotic, it was very hard, it was a very dangerous place, and it's a place that would just sort of like bring you to your, no, please. Come on, you had to add a little DNR in there. LA, jungle.
Wait, I'm curious, how many people get that reference? Of course we do. Oh, okay.
That was still only half the room, so. All right, we're showing the age on the audience stage. But I mean, the serious, it was very difficult at this time, right? And certain things, like we said before, they were fast but highly inaccurate, or maybe they were more accurate but they were very slow. But either way, it was just very, very, very painful. So we just wanted to add this in because it's slow and sloths are cute and they're in the jungle. But this is the time area that we're in. Things were slow. It just wasn't quite there. And now we enter a whole new world where you guys are in right now. A world that we're sort of calling the candy store phenomena. So I'm calling it phenomena.
Who gets the reference? Nobody. No, 4 people.
I'm just going to sling it.
Jacob, I told you.
But the candy store phenomenon is really what we're getting at here is this packaged goods. So if you look down on the shelves, things are nice and neat in the package. So if you have this jungle, it's crazy, it's chaotic, it's insane. But these are nice and neat in package.
Yeah.
You want to elaborate a little bit?
Exactly. So we came from the jungle where everything's very, very slow, very difficult, very kind of. It's very hard to parse a lot of the movement that's happening. But what's I think really exciting is now kind of modern man is emerging out of the jungle into the candy shop where if you want to do anything artificial intelligence, machine learning, facial recognition related, it's as easy as going to the candy shop and pulling out a package off the shelf. So I think we wanted to call out that, I mean, it's a really good time to be in this space because we're coming out where a lot of the PhDs and the mathematicians have done a lot of the hard work. And now, because of the likes of Facebook and Google and Twitter and a lot of these big companies that have made big investments in AI packages have neatly packaged up products like TensorFlow and Torch and Keras and others and made it available to us where we can leverage it without really understanding, gradient descent and a lot of those algorithms.
So I think some of you guys might have seen some of these things, but that means that we've kind of had this explosion of packaged goods, things that you just go out and get. So how many people have heard of some of these cloud services, like AWS Recognition, right? Cloud Vision from Google, Azure's Face API, Face++. Has anybody heard of Face++? No?
Oh.
It's Alibaba's cloud, so they pull API for doing things over there. So there's cloud services, you just go and get it. Tutorials online, and you can write a few APIs. But also in the libraries. We're going to be talking about Face API. PyTorch has FaceNet. So TensorFlow, PyTorch, whole thing there. Or if you don't want to do any code, you can just go buy it. There's companies called like FaceBurst or Animetrics or 3M's Cogent. And you can go grab this stuff off the shelf to get facial recognition. All of these pieces. So we've just entered this era of you used to have to write a whole lot of code, have to understand a lot, and now you don't need to as much because you can go get it off the shelf or you can get some kind of like packaged software. So, and this is a tiny, tiny fraction of what's really out there. This was a tiny amount. But there's one more thing that we want to talk about before we get into the code here, and it's this concept of where we were and where we're going. So this is my world. So now we're going to play some we're going to go on the age kick here. So my world, I just turned 40 this year. I started my career when I was like 19 working in data centers. And so I would set these things up. So I'd be in these cold refrigerated rooms with elevated floors, and I'd be running cables, creating routes, building servers. I have a heavy open source, so I did a whole lot of Linux data stuff. In grad school, I did MOS6 clusters. It's like what I did. That was my world in the data centers. And we still have those, but now they're in the cloud, and you don't have to be knowledgeable of the whole, like how do I build a data center and things. But 10 years ago, with facial recognition, and even still a little bit for some machine learning models, you do need to understand the data centers. You need to go back into those things because you need high computational power, right? But now we have this concept.
Learning on the edge. So, I think we see these shifts repeat over and over again in the industry where, a lot of the computation, in the days of the ARPANET, everything was very client-centric, right? That everything was connected together. And then we made this big shift to the cloud. And now with mobile devices, we're making the shift back onto the edge. And we have devices that can do the computation that 10 years ago required a large computer. I think a lot of that is, and now we call that edge computing, right? That's repeating itself in the learning artificial intelligence space, where we went to this data-centric approach, these huge machines that to run these massive models with thousands and even more parameters. But now we have these super powerful machines that are in our pockets. I actually run Ubuntu, a whole operating system on my phone, so we can do the compute back on the edge. We can learn on the edge. And now what this enables is, I think one is democratization of a lot of these machine learning, artificial intelligence benefits, where a lot of us can take part in it without having access to that massive infrastructure. It enables use cases that weren't possible before, where you can have agents that are learning within their context. I had a friend who did some work with a major oil company, and they built oil wells that kind of updated themselves based on machine learning models, but were very specific to the context that they were operating in, whether that was the cold of the Arctic North or the Texas desert and everything like that, and they can have different learning models without having sort of a master control. And then finally, I think it allows you. We're having a conversation as a society about data privacy and all of that. I think learning on the edge allows you to deploy these models and train these models in an edge context that doesn't require sending that data and sharing that vast amount of data back to the cloud, back to these central repositories. So it kind of gives a little bit of that buffer room when it comes to learning and training those models. So I think this is another. I think it shifts, as you guys you can probably tell. This is another shift that I'm really excited about, where we can enable learning, deploying models and training models on the edge and be able to, I think that opens up a whole new world of possibilities.
I think this is like the world that a lot of you guys are going to be living in.
Yeah.
This quote here that we thought was relevant, but things are going to get smart because they process their own data and formulate theories about the world. Meaning, we're about to go write some code. That thing could be a web browser. That thing could be a Raspberry Pi. It could be a phone. It could be your watch. It could be something super tiny. I found a whole facial recognition camera on Amazon. It was like $40. It was all processed in itself. So it came with a pre-trained model and could recognize the face within itself for $40. So these devices are going to be getting closer to you. And the last thing I'll say on this, because we're going off the age, I really want to make an Aerosmith joke here.
I don't even get that reference.
All right. So let's go ahead and get into things here. How many of you have heard of TensorFlow again? Okay, so good. I don't think we need to go too deep in that. TensorFlow.js.
Oh, good. Okay. Just a couple of.
Oh, that went down quite markedly. Okay, so we went from, hey, I know what TensorFlow is, to wait, TensorFlow.js? Okay. Well, you're going to learn about that. How many of you have heard of the face-api?
Not the Azure product, but the face-api JavaScript package.
Good. Yeah. Face-api.
Oh.
Anybody?
Okay, just a
Okay.
couple.
How about OpenCV? Open Computer Vision. All right. So we're like, okay. So a lot of TensorFlow, no TensorFlow.js. OpenCV, yes. Face-api for JavaScript, a little less. Well, what we're about to show here is the combination of what this whole thing is and writing some code here is a combination of these two libraries. So the whole introduction was about, hey, things are very, very complicated. Now we're sort of making things packaged. And these are the three packages that are important here. So TensorFlow, as you guys know, in the background, it's sitting in the background doing a lot of the neural network work. TensorFlow.js, making TensorFlow available via JavaScript. OpenCV, doing a lot of the computer vision. So that's the open source package of computer vision. And then the face-api on top of that, pulling in a JavaScript library to connect open computer vision with TensorFlow.js. So you get some of the computer vision work with some of the TensorFlow modeling and modeling and decision-making work, and mixing those all together. Anything you want to add to that, or go straight into?
I think we can go straight in. I have a funny story about OpenCV. My first initial exposure to computer vision was, I think in high school, there was this package on OpenCV that let you control the mouse of your computer with by looking at your face, and it would track your nose. So we're doing really important things with artificial intelligence.
All right. So a lot of that is what we've said here. It's really just to make things, easy, or maybe easier, or ish. So I think it's quite easy, but I think things are just getting easier. But there's so much more that we can do with this. But that's the idea, is that we have packages that help us write all of this code and take some of that complexity out. But I think understanding the background allows you to then extend it beyond what is just out there. And some of this is moving very, very quickly. Some of the code that Obaid's here and I'll swap your places, that's going to demonstrate, it was released in June. What are we, in August? And some of these features that we had, they came just out in June. So they're not more than 2 months old.
Okay.
So I'm going to set all this aside. Obaid's going to sort of flip screens here, and we have some code up and running that he's going to demonstrate, and then walk you through using these packages to build this.
So this is what we're going to be building today. See if I can get it to trigger. You can see it's got the emotion recognition right there.
It looks like P2.
It's really hard to trigger the sad. You have to try hard. It's kind of there. And then the last one is surprise, which is, oh. There it is.
That's definitely a surprise face.
Yes. OK, so who's ready for some code walkthrough?
No hands on that?
So just to level set some expectations, we're not going to dive into the details of MobileNet or YOLO or any of the models or the architecture. The point that we're trying to convey here today is that, like we were talking about of the candy store, these are things you can kind of pull off the shelf, and it's really, really easy to build something like this in a few minutes. So to get started, I'm going to get a web server running in the background.
So while he's doing that, what you can see here, go ahead and pull that up a bit.
Yeah.
All of those little things there, we're doing facial landmarks in that. It's identifying. So when you can see that, and feel free to go ahead and pull it.
Sure.
It's doing those lines around. So we're doing that background, that history. Like, oh, they found landmarks. Well, that's what that is. The landmarks around the eyebrows, landmarks on the nose, landmarks on the lips, and sort of identifying that. That's part of that history. Those landmarks were identified all the way back in 1960, and we've been building on that history ever since. You're just seeing it in real time in a computer, but that's the history of where it's coming from. And as facial recognition gets better, that's one of the many areas where we get better at recognizing, is having more landmarks, more things we can identify, more things that we can predict. What is a nose? What is an eye? What is a mouth? But then what is like maybe a crease? What is a chin? What is a cheekbone? What is a high cheekbone? There's more and more of these landmarks that'll come out.
Cool. So I've just got some basic HTML boilerplate here. Just some, just to get our kind of framework working. So I'll just say hello world here. And I've got a web server running in the background that I'm going to restart. OK. And I'm going to pull up the page again, and we're going to see magically nothing, except for the webcam. So this is just to level set. We are able to stream the webcam to the browser. Pretty basic stuff. If you have questions, we can talk after about that. But now we're going to get into the interesting stuff. So if I go back to the code editor, I'm referencing the script here. So I'm pulling in the face-api JavaScript. And by the way, this is publicly available on GitHub. So let me actually just.
So if you just search for GitHub face-api, you will pull that up.
The guy who put this together has a great username, just a dude who hacks. But he's got a really good set of documentation, and he does a lot of really cool stuff with face-api. Which I don't know if we mentioned this. The face-api is built on top of another one of this guy's modules, which is built on top of TensorFlow.js. And for those of you who are unfamiliar with TensorFlow.js, obviously TensorFlow is TensorFlow, but TensorFlow.js lets you take advantage of WebGL to do a lot of the same functionality totally in the browser. So with no other dependency, totally browser dependent. So we're going to pull in, we pulled in the face API, just have that downloaded locally. And then we've got some code here. If I can get it to go on the same window. So here, all I have going on is I'm pulling in sort of the video element. By the way, are we all comfortable with JavaScript? I can go a little bit slower if we have some people who are maybe good. Does that mean we're all comfortable or we're all not comfortable? So who's comfortable with JavaScript? All right, good. So I'll still try to walk through it, but at a high level, all we're doing is we're taking the video element of the page we had on the last screen, throwing that into a variable, and then we're taking the webcam data and just piping that stream back into that video element. So that's why you see the video in the other page, and then just running that function. So now let's do some machine learning. This is a short demo, so I have some sort of pre-prepared code. So the first thing we're going to do is pull in one of the models that the face API exposes. For those of you that are familiar, the face API JavaScript module, the models that it exposes is built on a network architecture called MobileNet. and the trained model is based on Tiny YOLO v2, I believe. And then he's got a pre-trained model that is specific for facial recognition. So that comes out of the box, out of the package. So we're just basically saying load in that model and then start the video. So we don't need this anymore. And then another thing I'm going to do to make sure we can take advantage of that model is add an event listener. And I'll walk you guys through what's going on in here. So here what we're doing is once the video is actually playing from the webcam, we're putting a canvas on top of that, and that'll come in handy a little bit later. But essentially then we're running the face recognition algorithm. And that's happening in this, I can't get my mouse to move. That's happening in this async function right here. Sorry, I'm new to this joystick mouse. Essentially what we're saying is that just detect single face. This is the one line right here that's doing a lot of the heavy lifting. And the face API exposes a few different APIs for detecting a single face, multiple faces, et cetera. But we're just detecting a single face from the video using the tiny detector options, which references the model that we pulled in earlier. And then the rest of it is really to help us draw that facial recognition on the actual page. So what I want you guys to take away from this is what it takes to actually create a real-time facial recognition application. The rest of it is fluff. This is the actual thing doing the heavy lifting. So if we
That's our candy store.
That's our candy store.
There's literally one line that's doing most of the heavy lifting because it's a candy store now. And then we can walk back to the entire history of, well, it's using a model, the model's trained on this particular network. That network is provided through TensorFlow.
Right.
That one line is doing all of that work for you. So it's taking care of quite a lot that you don't need to know about, but you can back into it.
Right. So OK, here's the moment of truth, live demo. I'm going to rerun the web server. And let's see if we can get some bounding boxes to show up. Should take a minute. It doesn't load up right away, so I have to see if it's... I was telling you before the thing that I hope it doesn't break during the demo. So let's see. Detections, roll detections. OK, let me try.
Now we're doing live debugging.
Live debugging.
You can bring up script 1.
OK.
Yeah, so what's going on in the background is this is running all locally. So the promise is there is a JavaScript library that goes and makes an async request and pulls in something, but it's just pulling from the same web server. That is pulling in face API is pulling in the TensorFlow.js and pulling that all locally. So all the JavaScript, like TensorFlow.js, is running on the computational power of that browser. That's what's going on there.
Oh,
and then obviously the script that we wrote is also running locally, just script.js. Is it not coming up now?
No, I think it was caching it, so I'm going to rerun it.
The pains of local software development and caching.
OK.
So while he's
there we go.
getting that up, lines 8 and 9, if you saw that, there we go.
There we go. So now you can see that it's actually recognizing my face, and it's following me around and putting a little bounding box. And it also tells you how confident it is that this is a real human face. So in some angles, I look really human. Some angles, I look, maybe like something else. So that's the first step. So now we can actually recognize the faces using the face API. The next thing we're going to do is see if we can project some landmarks on top of that. So for that, all we have to do is pull up another model.
So if you look at line 4, that tiny face detector at line 4, at least typing that in, that's the model that did the bounding box and recognized the face. So you have to first bring in that model. So it's a pre-trained model. that is included. So somebody took a whole lot of photos, and specifically this gentleman and some folks at Google took a whole lot of photos and said these are called faces. So how many of you are familiar with the machine learning concept supervised learning? Okay, that's what just happened. Somebody did all that learning for you and gave you the model. Because it's a face. It's built on 40 plus years of research that you don't have to go do.
All right, I'm going to load it in again. I've never pressed allow for any other website, but for this demo is the only time. So we were talking about privacy earlier, right? So what I've done here is I've loaded in a model that actually is trained on facial landmarks. So we were talking earlier about William Bledsoe, who had trained on kind of the distance between eyes and lips and et cetera. So this should load up any second and give us some of those facial landmarks. Oh, sorry, I forgot one piece.
So that extra function call was now saying, hey, I also want you to face detection dot with landmarks. It's referencing the model that loaded in with promises, so those two lines go together. Because it's an extra JavaScript function that says do this and also do that. The dot facial recognition dot effectively with landmarks.
Okay.
So you can see we're just building on top of it. It's that concept of that candy store. It's a package good. Just grab it and bring it in.
Sure. Okay. Get some more live debugging.
Your script 1, script 0.
Yep, that's it. Okay.
So it's these ones here. So these two line up with lines 4 and 5. So bring in the models, line 4 and 5. Call them right here. And then we're drawing things down in here. Draw the detection, draw the actual bounding box. Not find the bounding box, not find the face, just draw. So you might want to find the face but not tell people if you're creepy like that. But you're drawing it, or maybe you want to put something else on the screen. The probability is this. The probability is instead of like 0.96, you want to do 96%. You can change the way it's drawn. How many people use like Snapchat? How many people don't
There we
want
go.
to admit that they use Snapchat? This is LA. Well, I mean, that's what they're doing, right? If you use Snapchat or Instagram or P2 or any of these other ones where they're detecting your face and then doing something on it, well, they found the bounding box. They're just not showing you the bounding box. They use the landmarks. They're just not showing you the landmarks.
Right.
And then they're using in their code to do something with that.
Yeah.
Overlay across this box. That's all really Snapchat's doing. I mean, they're very sophisticated, not putting it down at all, but I mean, they're bounding boxes and then doing a video overlay. There you go.
Right. So you can see it's a little bit off-centered. There's some CSS weirdness going on there, but it's tracking my every movement of my face. So as I move my lips, you can see that the landmarks actually follow that. And if I move my eyebrows or move my head from side to side, the landmarks will follow.
Just delete the hello world string as a filter.
Delete the, oh yeah, that's it. You're right.
For those of you who didn't hear, the CSS office, because the hello world, put on the left-hand side, so it's shifting the actual, the DOM of the whole structure. You guys all raise your hand with JavaScript, so you're so we're having some alignment issues. It goes back to the bounding box is just a thing you could use or not. It has nothing to do with detecting the face. It's shown later. So you could show it somewhere else. You could do whatever you want with it.
So as we add on more models, it takes a little bit longer for everything to load up and run. Yep. There we go. So now it's right on top, and you can see how it's. So when we were talking about Snapchat, first you have to imagine when they project sort of like a different face or a puppy dog or whatever they have to do, they have to recognize what the face is so they can position the elements accordingly. So this is what's going on behind the scenes when they're doing that. I believe Snapchat's model uses a lot more elements than this one. This only uses 68 landmarks, but essentially it's the same concept. Okay, so now that we have these facial landmarks identified, the last thing we're going to do is layer on some emotion detection. Make sure I have the right script here. And for that, there's another model that gives us that information. Face expression.
So for the TensorFlow individuals, 4, 5, and 6 are really important ones because you see it says .nets, .this, .load from. So it's loading the model, but it's loading it into a network, which is then in turn using TensorFlow to do all of that heavy lifting and all that work.
Right. And it's worth noting, face-api actually exposes a number of models. We're only showing a couple here, but they have ones for age and gender and a lot of different things. And I was just reading a paper earlier today. There's a researcher out of, I forget which university he's out of, but they're releasing a face expression network that's got a lot more emotions. And we were talking about how these 4 emotions are just sort of subset. So as these emotions kind of come out, you can just load them in and run them. So I'm loading in the one that's for expression net, the emotion network, and then I just added that to our, to make sure that that's being called in, and then just drawing that. So if I save this.
So those who raise their hand are like, I use TensorFlow. If you built your own, like basically your .tf, and you have your whole models or your whole network that you're defining with your own weights, etc., you could do it up there. So then you wouldn't have to write all the JavaScript and the whole libraries of using your own network, using your own models. This would take care of a lot of the heavy lifting for you. Yeah. Which is a really key piece.
Right.
You spend all your time in TensorFlow, and then you write 3 lines in JavaScript. There it goes.
There it goes. So happy, kind of sad, surprised. So you want to see, just to show them that it's not just on my face?
I still want to turn this into a game.
Yeah.
I'm angry.
Yeah.
I'm neutral.
So the point there is, within, like, how long did that demo take? Like 20 minutes, we were able to build something that actually can, in real time, recognize your emotions just from the webcam. So super edge learning, candy shop, right off the shelf.
So we have some time. We want to leave some time for some questions, and then lunch is coming up. Are there any questions out there?
Any good resources or books or websites you can recommend for?
Yeah. I would say honestly the best resource is just to build something. There's tons of books. There's tons of everything. Google is probably your best friend there. There's like always articles on Medium that will tell you a lot about this. But once you go through the process of building it, it will open up a whole new world for you that no book is ever going to be able to do, in my opinion.
Also say the face-api on GitHub is awesome.
Yeah, it's really well documented.
So does that stack also allow me to extract the metadata so I can compare it to an existing picture and do analysis on it?
You mean if you wanted to extract like the emotional information?
Yeah.
Yeah. So if you look at the code,
You're rather doing like a still image.
Still image,
Yeah.
like a still image like a driver's license.
Yep.
right. So basic.
That supports it, that's all I need to know.
Yeah.
So, can you just stay for like 5 minutes so that the others asking questions, they don't get disturbed? Just 5 more minutes, I'm good. Thank you.
But to answer your question, you can log out to the console any of the emotion information, or just take a snapshot and save that to disk, whatever you needed to do.
So we're willing to stay around and answer some questions if you have like a burning one you can. We do understand food is very pressing. So.
There's one last question.
Well,
Is that like more than 80% of the people here in the room are starting their career or maybe are students? Would you recommend them directly starting with like APIs, or would you recommend them starting from scratch, understanding gradient design, how your networks work?
I think either
So-
could take it, but.
So I've tried both approaches. I would definitely recommend starting with the APIs, because the feeling you get of something that's like working and actually doing something is so powerful that lends itself naturally to kind of go deeper and deeper in understanding all those deeper algorithms and network architectures and all that kind of stuff. But if you start with try to understand gradient descent, and now you're thinking and trying to think in like 8 dimensions and stuff. That's a much more, a much taller order in my opinion. So as you're starting your career, I would definitely say start building, start creating things, start actually making something that works, and then go deeper and deeper down the rabbit hole and get into the science of it. So,
Thank you.
yep.
I mean, I'm going to echo that. I have a lot of people on my team. Recently, I have a number of recent college grads, just came out of school. There's no expectation, even if you come out with a master's degree, that you're going to understand how a neural network works in the real world. Like, we just don't have that expectation. But there is an expectation, like, can you just write an API or so? I also think that starting with APIs gives you this ability to determine where you want to go, because this field is still so new. So we have a slide here in the back that is like, this is detecting 4 or 5 emotions, right? AWS recognition does 8 emotions. But in the field of psychology, there's somewhere between 27 or more emotions. But you get to decide, well, do you want to write the application that uses that and then wait for the technology to catch up? Or do you want to go dive deep and get into the psychology to build the landmarks, to build a neural network, to go get trained on that? It's a huge difference. It's like a very, very, very big difference. Like, we haven't figured out in computers how to figure out what boredom is, and to be able to look at somebody and say that person's bored through a computer. Yeah. But heck, you could do this and go write like Snapchat and P2 and do a whole bunch of cool things and, do overlays and have fun with it.
Right.
Would that stack recognize 2 people at the same time if they were both up there?
It does. So we're using, just to kind of...
Yeah. Not with that function. This, you call it a different function.
Okay.
We use with single face, so you just call it. Yeah.
Yeah.
And then...
So we can change that option.
We can probably take one last question. This is our time.
Yeah, my question was specifically, you were talking about how everything's so accessible now, and with that being said, do you think that like the role of data scientists might kind of somewhat trend towards being less people employed because things become so easy to do that you have automation software packages, like in the same way that everyone uses Excel and just click buttons,
Yeah.
using that face recognition and a broad array of algorithms will trend in that direction?
Do you want to take it?
So here I would say my quick is yes and no because of what I just said. So yes, some things are going to get easier and automated, but no, because those things are not that great. And we probably have a good 5, 10, or 15 years before they get to the point of being replaced. Like, facial recognition is pretty easy to do, as you saw. Is it perfect? No. I mean, pick up the newspaper and look at all the lawsuits and this and that are happening. It's not. There's still a lot of work to be done. So please come into the field and be the part that's going to fix it.
My answer to that question would be an emphatic no. I don't think it's going to be less data scientists employed, because I think as you increase access, there's going to be whole new problems. So we were talking today about edge learning. There's a paper that Google put out a couple of years ago explaining the same concept. If you guys are interested, it's called Federated Edge Learning Feel. And they describe an entirely new architecture where you have these devices on the edge that are learning, but updating a model that's centrally located. So that's a whole new problem, a whole new kind of area. And I think those things are, to Jacob's point, because this field is so new, there's going to be whole new challenges, whole new problems to work on. And then in parallel, all the different network architectures, there are still tons of papers every year coming out. So it's, as long as that fuel keeps coming in, I think the field is going to keep growing, and the demand is going to keep growing.
And this is just like face recognition, object recognition, there's animal detection. Is it a cat? Is it a dog? Is it a fancy cat? Is it a big cat? Is it, is it a cat or a tiger?
Yeah.
So many things. It may look like it's easy, but it's really the very, very beginning. Very, very early.
Hot dog or not a hot dog? Okay.
All right, we're welcome to stay around.